than ever before as we journey through its ferocious atmosphere. Let's explore what I'm sure you all agree are the fascinating phenomena that materialize there. I'm Alex Molan, and you're watching Astro. And in this video, I want to dive into the sun drawing on different wavelengths of electromagnetic energy to showcase the star in a new light. Previously, we've explored Jupiter and some of its moons through the lens of the electromagnetic spectrum, which you can see in this video. Here today, we will be revisiting this approach, but this time, rather than a planet, it'll be adapted to investigate a highly energetic B-wall of plasma. The light we'll be looking at is old, although light is the fastest thing we know. The image of the sun that we see from Earth is approximately 8 minutes and 20 seconds old, meaning we are viewing what the sun looked like a few minutes in the past. And if you count how long it takes the photons generated within the sun's core to make their way through each layer of the sun before escaping into space, the light that reaches us is anywhere from 10,000 to 170,000 years old. Where to begin, like eating a fruit, by starting with the outer layers and working your way in. Let's start our investigation with the outermost layer of the sun's atmosphere, the corona. The following image was taken by the Solar Dynamics Observatory, or SDO, a NASA space mission launched back in February 2010. SDO aimed to better understand the solar variations that influence life on Earth and our technological systems by studying the dynamic solar surface and atmosphere at different electromagnetic wavelengths. By looking at light beyond the visible range, NASA was able to pick out normally invisible details crucial to our understanding of the sun. This image was taken using a 19.3 nanometer wavelength representing light found in the extreme ultraviolet region, at a wavelength responding to a color temperature of 1 million Kelvin. We can clearly see the higher region of the sun's corona. Interestingly, the sun's corona can also be seen by the naked eye, on rare occasions such as during a total solar eclipse when the moon is perfectly aligned between the Earth and the sun. For a fleeting period of time, the view of the central brighter disk, known as the photosphere, is fully blocked, revealing a radiant exterior. While this is a breathtaking view, already the corona is still nowhere near as detailed as it is in this image taken by the SDO. This makes it a useful tool for scientists' studies, but let's go a little deeper to features of the sun just beneath the corona at a color temperature of 20 million Kelvin. The intensely vivid spots indicate events known as solar flares. Here is some footage of a particularly busy week for flares back in August 2022. I've always found solar flares to be both terrifying and hypnotizing. They are colossal explosions where the sun spews out an immense amount of electromagnetic radiation. They are caused when magnetic fields distort, and reorganize themselves rapidly. This activity is created by the turbulent nature of the plasma within the sun itself from which the fields ultimately originate. But they are not the only feature of the sun's atmosphere. Venting radiation coronal holes indicated here by this darker region on the sun are another fascinating feature which we'll take a closer look at. Using extreme ultraviolet light, coronal holes are areas of cooler, less dense plasma, which are magnetically open, meaning that rather than forming closed loops that go back to the sun's surface, the field lines travel outward across the solar system. These areas allow solar wind particles to escape more easily into space when these solar winds are directed towards and collide with Earth's magnetosphere. Beautiful, aurora lights dance across the night sky at the Earth's polar regions. Using ultraviolet light gives us a much better view of these fascinating features of the sun's outer layers. Non-visible spectrum. Light is an incredible tool, and there are so many different features in the sun's outer layers to look at. There are solar filaments, known as solar prominences, the large loops of plasma that rise from the sun's surface. These enormous loops are large enough to make the Earth look like a tiny speck and can stretch hundreds of thousands of kilometers into space. They can form in as little time as a day, but a stable prominence can remain in the corona for several months. In this example, we watch as a solar prominence snakes its way out of the photosphere and into the Sun's atmosphere. Although this video is sped up, so the minutes seem like seconds. When you consider the size of the prominence, it becomes clear how swiftly the Sun's intense magnetic fields are causing this material to move. One fact you might not know about the Sun's atmosphere is that it sometimes rains. There, not all of the charged plasma fired into the Sun's corona continues out across the solar system. Some remains in the corona, getting trapped and cooled until it falls back to the Sun's surface as a shining rain. This coronal rain is beautiful to look at, but is best observed from a distance. It's still millions of degrees in temperature. Of course, falling gently back to the Sun's surface is only the fate of some of the Sun's plasma. This is where the comparison to Earth fails after all. On Earth, the clouds do not crack like a released elastic band firing into space on the Sun, thanks to tightly wound magnetic fields. They do this as a time-lapse of a coronal mass ejection watch, as the structure forms at the bottom left of the Sun for some time before eventually snapping and sending billions of tons of plasma out across the solar system. Even with the Earth's magnetic field being hit by a powerful one of these could be devastating for our satellites and electrical grids. All these